All right, percentage problems. Another example, further examples on percentage. Let me just keep my calculator here. Ropi Mets, okay. So another example, guys, as you see, the examples are simple, but here maybe you have never did or done such examples in English. Okay, you're going to enrich your vocabulary. You're going to be familiar with some words in English. Maybe some of you may take some business classes or financial math. At that time, it will help you to understand better. Okay. So in a school library, 28% of the books are classified as fiction. And the remainder means it is 72%. It is non-fiction. So we are talking about two different types of books, right? Given that there are 1,980 more non-fiction books than fiction books. Find the number of books in each category with the total number of books in the library. Okay, so now if you just make a table, small table to describe this, and let me just draw 3 rows. Okay, and here we have, just right here, here we have fiction books and non-fiction books and total number of books in the library, right? Let me write here as percentage. In a school library, 28% of the books are classified as fiction. So fiction, it is 28%, non-fiction, 72%. Together, they constitute the total number of books in the library, right? And given that there are 1,980 more non-fiction books, right? So that means that how many fiction books we have here, we don't know. Let's say we have n fiction books. And since the number of non-fiction books because of this person is more, by how much? 1,980. So that is n plus 1980. Okay. So this total number is, it is 100%. And here, what is the total number? It is 2n plus 1980. Okay. So find the number of books in each category and the total number of books in the library. So we need to find this, right? The total number. First, 28% of the books are fiction books, and what is it? 72% is n plus 1,980 books. Anything given? All right, collaborate. Okay. Now we need to form our equation, right? Nothing else. Everything is given, it's in the table. Okay. So solution. What is the total number of books? Total number of books is 2n plus 1,980. So I can use either this equation or this equation because 28% of these books are fiction, right? So that means that 28% of all the books, yeah, this line is 28% of all the books, right? How many books in the library? 2n plus 1980 is equal to, and it is fiction. How many fiction books we have? We have n fiction books. All right. Another version is also actually 72% of this, all the books is n plus 198. It doesn't matter. You form your equation using these two things or these two things. After all, you'll get the same results. Okay. So that is our equation. Okay, we have read the problem and just draw a table and describe the data here. Now using this data, we form our equation. Now we have to solve this. 28%, we know that it's just 0.28 times 2n plus 1980 is equal to n. So we have to solve this equation. Remove the brackets. This one is 0.56 n plus 0.28, 0.28 times, what is it? 1980, 1980. That's equal to 554.4. On the right hand side, we have n, right? Now, if I just take it to the right hand side, here we have n minus 0.56 n is equal to 554.4. And what is 1 minus 0.56? That means 100 minus 56. That is 0.44. N is equal to 554.4. Or from here, n is equal to 554.4 over 0.44, which is equal to 544.4 is divided by 0.44, which is equal to not a good number. 0.28 times 1980, 55.4. Okay, 0.44. 28%. It is n, 2n plus 198. Fiction. 72. Non-fiction. Okay. 2n plus 1982 total, and 8% of 2n plus 198 equals n. It is 56, 554n. Okay. 554.4 is divided by. All right. So everything's okay, I think. 554.4 is divided by 0.44. That's equal to 11260. Okay. So now we can write our answer. F, number of fiction books, how many? 1260. And number of non-fiction books, 12960 plus 1980, that's equal to 3240. And total number of books in the library is the sum of these two things is equal to plus 1260, that's equal to 4,500 books. Okay. So in the school library, there are 1,260 fiction books and 3,240 non-fiction books, and altogether there are 4,500 books. Okay, let me just write it somewhere because we are going to need this in the second example. Fiction books 1260, non-fiction books 3240, and total number of books 450. Okay. All right, Bongkong, is it clear?
Yes, sir.
Oh, thank you very much. You are there, right? Good. Rose is on is trying again. Let's see, she can join this time. Okay. Next, B. The library decides to increase the number of non-fiction books by 7.5%. Okay, 7.5%. What books? It is non-fiction books, right? Non-fiction books. At an average cost of $15 per book. Because now the library decides to bring some new books and they are going to increase the number of non-fiction books by 7.5%, and each book costs an average $15 and the number of fiction books by 5%. So it is $4.50 per book. Calculate the total cost of the new books. So now the first part is we need to calculate the total cost of new books. Let me just simple write this T total cost, okay, TC, okay. Now the first, how many new non-fiction books we are going to buy? Okay, so we need to calculate this one, right? New fiction books and new non-fiction books, or I can just write F maybe. All right. So how many fiction books we have from the previous question, right? Fiction books, 1,260. 1,260. And how about non-fiction books? 3,240. Now we are going to buy a bit more, right? So to find the number of new books, I should multiply this by this percentage. So that is 7.5%, because we are going to buy this many new books, right? We are going to increase by 7.5%. And how about non-fiction books? This fiction books, 5%. 5%. This one is 7.5%, which is equal to 5% means 0.05. So 0.05 times 1,260, that's equal to 63. So we are going to buy 63 new fiction books. And how about non-fiction books? It is 7.5, that is 0.075 times 3,240, that's equal to 243 new fiction books. And what is the average cost of fiction books? Average cost of fiction books is 4.50. It is 4.50. And average cost of non-fiction books is $15, right? So now to answer this question, the total cost, right? So this one is 63 times each is 4.50 plus, and this one is 243. Each book costs on average $15. So we have to spend this much money to buy these new books. So that's equal to 63 times 4.50 plus 243 times 15, which is equal to $3,928.50. Okay. So actually the university should spend this much money if they are willing to increase the number of fiction books by this percentage, and if they're spending around $15 for each non-fiction book. And they're going to increase the number of fiction books in the library by 5% and going to spend 4.5 on average for each book. Number two, the percentage increase in the total number of books in the library, right? So how many new books are already bought? So this many fiction new books and this many non-fiction books, right? It states that the percentage increase in the total number of books in the library. Percentage increase in the total number of books in the library is, so we added this many books, new books, right? And before, how many books we had in the library? If you remember, it was 4,500. So we are going to express this new books, number of new books, as a percentage of the total number of books in the library. So that is 100%, which is equal to 63 plus 243. 243 is divided by 4,500 and multiplied by 100. That's equal to 6.8. So that is 6.8%. So overall, by adding 53 fiction books and 243 non-fiction books, we have increased the number of books in the library by 6.8%. Okay. Bong Kong, did you understand?
Yes, sir.
Very good. And I hope if you understood, it's clear everything, right? Can you hear me well, Bong Kong?
Yes, sir.
Now, what are you using? Are you using telephone or PC or laptop?
I use tablet.
Tablet. Oh, very good. Now, what is the screen size of your tablet? 10-inch or 7 or 8?
10.5, sir.
10.5. Very good. Okay. Guys, now I'm going to finish the first part of this chapter, okay, 8.1 and 8.2. And I think I have already uploaded this worksheets in the classroom system. We can download and continue solving these problems. And about assignment for chapter 8, I'm not going to give you this assignment, but you have to solve all the questions, okay? As many questions as possible, if possible, all the questions. And you don't have to submit, okay, your assignment, just do it for yourself. I don't know, should you want to do assignment or not, Bong Kong?
No, sir.
Okay, I will let you know, let me think, okay. And because of, instead of giving assignments, should I give 2 quizzes or project? I'm thinking about this. Let me decide and I will let you know, okay, maybe tomorrow. And because it's a very important chapter, I want you to solve all the questions. Maybe the previous chapters, you could skip, like solve 1 question, skip 2 or 3 questions. But in this chapter, if possible, you have to solve all the questions. Okay, so really useful for your whole lifetime. That's why it is important. Anyway, guys, I'm going to finish chapter 8.1 and 8.2. We just keep solving the questions. If you have any question, we can discuss tomorrow. Now we are going to talk about simple interests. Okay. When we say interest, the first thing that comes to our mind is, what is it? Banks, right? So when you deposit money into a bank, you receive interest for allowing the bank to use your money. And similarly, when you borrow money from the bank, you must pay a certain interest for using its money. So interest in both cases is calculated as a percentage. We call this the rate of the capital. We call this the principal, and deposited or borrowed. So interest is sometimes calculated at a fixed yearly rate called rate per annum. And simply, this is the simple definition or description of simple interest. When we talk about interest here, we are going to talk about 2 different interests. Number 1 is simple interest. Number 2 is compound interest. And third one is continuous interest. Continuous interest, we will see this when we learn or when we study logarithms. Okay, because when we talk about continuous interest, we are going to use exponentials, and we need to have some idea about the special number e. Okay, so I'll just defer this to the later chapters. Maybe in chapter 9 or 10 we'll talk about this. So now here we'll talk about 2 different interests. Number 1 is simple interest. Number 2 is compound interest. Okay, the simple formula is interest. Simple interest is calculated using this formula, PRT over 100. And P is the principal, the capital, R is the rate, and T is the time. And if you ask how do we get this formula, it is very simple. It is very simple. And now I'll just explain this. And here, amount. Amount means in your balance how much money you have by the end of this certain period of time. That is principal, that is the money that you deposited or that you put into the bank, and plus over a period of time your money earns some interest. Also this interest is yours because that's what is it? This interest is added to your principal, and now in your balance you have this much money. So that is described as an amount or balance or your capital. No, not capital, actually it's amount. Okay. A man borrows $100 for 3 years at a rate of 6% per annum. What is the simple interest he has to pay? Okay, while we are selling simple interest, what is going on here? So you are depositing $100, right? So your principal is, let's say P, your P is $100. Okay, and time, for how many years? Time is 3 years, 3 years. Okay, let me just write YRS, that is years. At a rate of 6% per annum. Rate is 6%, but sometimes instead of this percent, we can just write this as a decimal, because this rate, small letter, what is rate here is 6% is 0.06. At that time, we have to use this formula. I is equal to PRT. Okay? Or this PRT, this I equals either PRT, that means that this R is in decimal form, or capital P and RT over 100. The same thing. Maybe here is a just number, but here is a decimal. Okay, and rate over 100 is just equal to R. But usually we prefer this one. Immediately change this into decimal and use this one. What is the simple interest he has to pay? So we need to find this simple interest. Okay. So what's going on here is 3 years means you are depositing, actually you're borrowing money from the bank. Okay. So here we have the first year and second year and third year. I mean, here the first year means the whole year, right? 365 days, 365 days, 365 days, right? And you borrow the money on these dates. Okay. So you use this for 1 year. Now at the end of the first year, the bank calculates, okay, this guy borrows $100 from me. So 1 year is over. Now for the use of this money, he has to pay 6% of this 100 to the bank, because you're using bank's money. How much is it? It is 0.06 times 100. Okay. Now, okay, the second year starts here. All right. But now in the second year, again, bank is not using this amount. Okay, 100 plus 1. It's actually, again, is calculating on this based on the original principal. That's why we call this simple interest. Now the second year starts. Now again, you're using this $100, maybe all, it doesn't matter. What you borrow from the bank is $100. At the end of the second year, again, bank actually just sits, and I mean the banker, whoever it is, sits in front of the computer PC and opens your account. Okay, that is due already. So again, you have already used this $100 for the second year. Now we have to pay 6% of $100 for the use of this money, which is equal to 0.06 times $100. And the third year, the same thing repeats, right? It is 6% of $100. That's equal to 0.06 times 100. Now you may continue if you borrow for 4 years or 5 years or 10 years or 20 years, it just continues. If you notice here, every time we calculate this is the same expression, right? The same expression. And how many such expressions we have? Actually, there's 3. The 3 equals the number of years that we borrowed from the bank. And that's why we are multiplying by T. This P is our principal. This rate is this one in the rate, right? And this T is the time. How many? 1, 2, 3. And that's why we are using this formula to calculate the simple interest. So to answer this question, then interest is equal to What is the principal? It is 100 times. How about the rate in decimal? Decimal is 0.06. For how many years? For 3 years, which is equal to $18. So that means that at the end of 3 years, you have to return $100 plus $18 to the bank because you have used the bank's money. Okay, and that's called simple interest. Why simple interest? Every time at the end of each period, when we are calculating the interest, we are using this original principle. Okay. Another case is compound interest. We'll talk about this a bit later. All right, another example. Now you got the idea, I hope. If not, you may ask at any time. I'll go a bit faster. Okay, so when you're solving the question, first write given information. 10 minutes left. Okay, I will finish maybe after 2 examples. Mary needed capital for her bakery. Okay, Mary is maybe a graduate student or just a student or a person who's going to start a business. So she may not have enough money and she's going to do what? Bakery business. She borrowed $60,000 for 4 years at a simple interest rate of 8% per year. So the capital, the principal is $60,000 that she borrowed from the bank. For how many years? Time is 4 years. Okay. Simple interest. What is the rate? Rate is 8%, which is 0.08. Question A. How much interest must be paid to the bank? The interest is equal to PRT. And what is the principal? 60,000 times. What is the rate? 0.08. And how many years? For 4 years, which is equal to, so it is 60,000 times 0.08 times it is 4, which is equal to $19,200. Okay, so at the end of 4 years, for the use of this amount of money, that is bank's money, we have to pay additional 19,200. Okay, that is the interest we are paying to the bank. And B, how much money will Mary pay at the end of 4 years altogether? And how much money you're going to pay? That is amount, right? You're going to pay back this principal, right? And the interest earned by this principal. And what is the principal you borrow from the bank? It is 60,000. And how about the interest? It is 19,200, which is equal to $69,200. So at the end of the 4 years, the money that you borrowed, it earns 19,200 as an interest, and you have to pay back this amount of money to the bank. Okay, Bunlong? Are you there, Bunlong? Or eating lunch? Guys, let's see what is next. If it's simple, we can solve one more example and I will finish the class. That is the last example for today. Okay, so if possible, you need to start practicing 8.1 and 8.2 and 8.3. Okay, example 6. To save money for a bookshop, Ronald invested $2,500 at 6% per annum simple interest. Investing means you are depositing your money, right? Or you are keeping your money in a bank. How long will it take for the amount to add up to 3,400? Okay. Of course, in real life, we usually do not do this. It takes a lot of time. It's just example related to simple interest. This guy has $2,500, okay, and but he needs $3,400. Okay, maybe what is it? It's for a bookshop. But now he's not going to. He's so busy with maybe with his studies or some other stuff. but also he doesn't want to keep this money in his pockets. And the question is, if he invests his money into a bank, and if bank pays 6% simple interest per annum means per year, right? Per year, how long will it take? How many years he has to wait for his money to grow up to $3,400? Okay, that's a question. So principal is given here. It is 2,500, and the rate also, it is 6%, which is 0.06, and the amounts, right? Amounts is equal to $3,400. Okay, what is the question? Question is, how many years does it take, or how long will it take? To solve this question, we need to use this formula, right? Amount is equal to principal plus interest, right? Or from here, what is interest? Interest equals amounts minus principal. Now, if you just write the formula, what is interest? Interest is PRT is equal to amount is given minus principal is given, right? And we know how to make a given variable the subject of the formula. We know P, we know R, we need to find T. So what is T? T is equal to A minus P over PR equals, what is A? 3,400. 3,400 minus, and what is P? P is, principal is $2,500 over principal, it is $2,500 times, how about the rate? It is 0.06. And if you calculate this, T equals, what is it? 3,400 minus 2,500 over 0.06 times 2,500, which is equal to 6 years. So he has to wait for 6 years for this money to grow up to 3,400 at this rate. So it's a good rate, of course, in Cambodia. If you visit a few banks, usually if you deposit your money, the interest rate is very low, right? It's about 2.5%, maybe 3% or 3.5%. But if you get a loan from the bank, it's very high, maybe 18% or 15%, something like this. Actually, that is bank's profit. This is how banks make profits. Okay. Chinkui. Chinkui. Okay, maybe he's busy. Guys, I'm going to finish today's class. We'll continue tomorrow. Okay. And again, I'm going to put this in YouTube if you want to watch later. If you have any questions, you can ask your teacher assistants or you can ask me in Telegram. Okay. Thank you very much. See you tomorrow. Bye-bye for today.